Yeah. So to push data to pull data, that was what we were talking. So what makes data pulling possible? Data pooling is possible because of this learning algorithm, machine learning algorithm, and every day we are generating a huge database or data, and that makes this pulling data is possible. So every day, this is the statistics. Facebook processes 24 petabytes of data per day. Google, upload 10 million photos every hour. YouTube, 1 hour of video uploaded every second. Twitter, 400 million tweets per day. Satellite data and other applications that we are using every day, that is not taken into consideration in this particular slide. But we have generated up to 44 trillion gigabyte data by year 2020. That is last year. And this source is digital universe opportunity, rich data, the increasing volume of the Internet of Things, uh, taken from April 2014. And the data that we generate, that is in multiple form. We may have data in textual form or documents, numbers and digits, click streams, graphs. So it is multi featured data that we are generating every day. And some of the big guns, they are for say this machine learning, the future of machine learning like this. Bill Gates, he thinks through breakthrough in machine learning would be 10 Microsoft. The machine learning has got capability or potential of uh, 10 Microsoft companies. Similarly, the director DARPA, he says machine learning is the next internet. President of Stanford University, the vice chancellor of Stanford University, he says that machine learning is the hot new thing. Prabhakar Raghavan, director Yahoo, web ranking today are mostly a matter of machine learning. In ranking, machine learning is used. Similarly, machine learning is going to result a real revolution. That is CTO, Chief Technological Officer of Sun Microsystem. He thinks like this. This is the CEO of Yahoo. Machine learning is today's discontinuity. Whatever continuity that we are in computer science and IT industry, that is broken by machine learning techniques. So this is what the machine learning, the potential of machine learning is. And some of the definition, in fact, there are so many definitions, number of definitions of machine learning are there, but probably this definition is probably the best definition, that is given by Tom Michel in the 1997. A computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task T as measured by P improves with experience E. The bottom line is, with every learning, if the machine learning algorithm or the algorithm improves the performance, then it is called a machine learning algorithm. And that is what this Tom Michel is saying all about. This is machine learning process. I guess all of you are teacher and teaching machine learning or learning machine learning, so this is not new for you. So we give some data, and this data is broken into or divided into two parts: training data set and testing data set. And training data set is used for training the model, and then final model is created, and that model is tested, and some prediction or classification type of tasks are performed. So this is learning. Learning is any process by which a system improves performance from experience. So in one of the slides earlier, we talked about is it possible to program experience and common sense? If we use our experience, our performance improves. So we learn and we improve our performance. So what we do, can we get it done by the machine? And if we can get it done by machine, that is done by learning experiences or learning process. And similarly, I will not spend much time on this definition part, but these are some stalwarts who talks about machine learning. And one thing is in common. If you will see the last definition, machine learning refers to a system capable of autonomous acquisition and integration of knowledge. If we integrate knowledge in our algorithm, and if the performance of that algorithm improves, that is what the learning is. Learning, machine learning, for that matter, is divided into three parts. I will talk today. I will talk about supervised learning, but this learning, there are of three types: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is performed under supervision. What supervision? That is that what supervision takes place, that we discuss in supervised learning method. Along with the inputs, we also give outputs or the target. That is what the supervised learning model does. For example, if we have data of breast cancer, for example, this is very well known example. University of Wisconsin has generated this breast cancer data set. They have identified some of the features like what is the size of the tumor, what is the color of the tumor, what is the radius of that particular tumor, what is the thickness of tumor. They have identified certain characteristics or certain features, and on the basis of those characteristics of features, they have also recorded whether the patient is suffering from cancer or not, yes or no. So that is one example. That is one example of a data set. And one another data set, that is fuel data set. Here, what is the horsepower of the vehicle? What type of vehicle it is? It is petrol vehicle or diesel vehicle? What is the cylinder, what type of cylinder that vehicle is using. So on the basis of this type of feature, they try to forecast what will be the CO2 emission. So here, if you compare these two data sets, the target in the first data set is categorical, whether patient is suffering from cancer or not, yes or no. And in the second example, the amount of CO2 emission is predicted. So CO2 emission would be 175.24 or 130.73, something like that. So here the target value is continuous in nature, whereas in the first example, the target value is categorical. So when we say supervised learning, while training, we give all the features along with the target value. Target value is supervised type of thing. So we give the features and the target for training. So when we use that type of technique, then it is called supervised technique. And in supervised technique, two type of tasks are performed: prediction task and classification task. The example of breast cancer, where the target value is categorical in nature, then it becomes the example of classification. Whereas the continuous, in case of continuous target value, the example becomes, or the task becomes, prediction problem or the regression problem. Similarly, unsupervised learning, we do not use a target value while training. And clustering or association rules, creation, this type of examples are example of unsupervised learning. This type of problems can be solved by unsupervised learning. And reinforcement learning, it is reward based learning. So if some task is performed, then we give some reward to the process or the algorithm, and if the task is unsuccessful, we do not give reward to the process or the algorithm. So that type of algorithm is called reinforcement learning. uh, as we discuss yeah, as we discussed, this data set is divided into two parts. Data set is divided into two parts. One is training data set and another is a testing data set. So first of all, in training data set is required to be transformed. Some of the examples, say for example, the price of a house. So for predicting price of the house, generally price of the house is in lakhs of rupees. On the other side, how many rooms are there? That is one of the characteristic of or one of the factor which affects the price of the house. So that is one feature. What is the locality? That is another feature. What is the size of the house? That is the third feature. If you consider these four aspects or these four factors, you will come to know that the size of the house may be in square feet, 3,000 square feet or 4,000 square feet, something like this. The second one is number of rooms in the house, 3, 4, 5 rooms are there. Then locality, post locality or what type of locality, and then the
ये
cost of
बंदा
the
तो
house.
बोल रहा है इसने इसको याद नहीं कि इसने 5,000 भी दिया है और इसको ये भी नहीं मालूम इसका कोर्स वर्क हुआ ही नहीं। बोले मेरे पास कोई फोन वोन नहीं आया मैडम, मैंने तो कुछ भी नहीं किया। ये इससे बात करवाई अभी।
Okay, so if you consider these factors, all the factors are, one cost is in lakhs, uh, size is in thousand, number of room maybe 1, 2, 3, 5, so within 1 to 10, and locality is categorical. So all these, data or the features are different in, different types of numbers. So range is very big. So we can do one thing in machine learning. If this type of data that we get, then first thing that we require is to normalize the data. Sometimes if categorical data is there, color of the color of tumor, for example, in the earlier example, color of tumor, that was considered as one of the feature. So red or brown or black type of color, color of tumor is there. So we can change from categorical or color name to the codes. So 1, 2, 3, 4. All these type of things are considered as taken care of in transformation method. So training data is required to transform first, and then training is done. Uh, to give data label are also required. So here data label is also provided, if you can see here. So along with this here this data label is also provided along with the inputs. So this here training takes place, and then when training is done, then once again transformation on testing data set is performed, and then model is tested for prediction or classification. So this is a supervised learning method, and these are some of the algorithms of supervised learning method. The algorithms are KNN algorithm, decision tree algorithm, random forest, naive-Bayes, support vector. I will show you today in some of our projects how we have used KNN algorithm, support vector machine, artificial neural network. We have used all this data, all this type of algorithm in Gujarati language processing. Unsupervised learning method, the arrow which was available over here, this is not there. So here we simply give inputs, without targets or without the output predicted output, and the method or algorithm is trained and then it is tested. So this is the basic difference between supervised learning method and unsupervised learning method, and these are some of the algorithms of super algorithms which fall under unsupervised learning. So this is what we do in what we have done and what we are doing in language processing. We in our department we are doing a lot of work on Gujarati language. So handwritten Gujarati character recognition, I will demonstrate. I will show you some of the beginning or initial work of numeral and alphabet recognition. My main intention is to demonstrate what type of algorithms are used for optical character recognition, specifically handwritten numerals and handwritten alphabets. We have completed this Gujarati spoken numeral recognition. Suppose I speak something like this, 1523. So based on the spoken wave file, we try to convert that spoken number into editable text. That is also Gujarati language processing application. Online Gujarati optical character recognition, that is done, that is completed. There also all the projects include or use uh, machine learning algorithm. And here Gujarati grammar analyzer. So how grammar is analyzed, whether some statement is written in Gujarati is grammatically correct or not, as it is done. And I know that Punjabi University is doing excellent work in Punjabi grammar analysis or grammar. They have created grammar analyzer and they are doing wonderful work in Punjabi language processing. The next project is if some picture is there and picture contains some Gujarati text, headings or subheadings or something like this, which is written in Gujarati. It identifies, it localized, first of all it localized where the text is written, and after localizing the text, it also identifies what exactly it is written. So that is what the things done in language processing, uh, 1 2 3 and 5. Projects are of course based on machine learning algorithms, but they are not uh, done on language processing, so we will not discuss anything. We have started Sindhi grammar analyzer also. Punjabi University is also doing on in Sindhi, but we are doing Devanagari Sindhi. So this project is going on, and the last is Gujarati sentiment analysis. So all this project 1, 2, 3, 4, 5, and 9 and 10, these projects required some language processing concepts or language processing foundation. So these are the algorithms that we are using. Now, let us first discuss what makes Gujarati language processing different from other language processing. At this particular point of time, we will
Excuse me,
discuss,
sir.
yes,
Can you just show us the algorithms once again?
algorithms,
Yeah, just
the list of algorithm.
yeah, list of it.
List of algorithm is this.
Thank you, sir.
Okay. So here we will discuss the characteristics of Gujarati language in OCR perspective. So, as you know, Gujarati is used in the state of Gujarat. It is used by more than 5 crores of people, 5 to 6 crores of people staying in Gujarat, and all across the globe. Important thing is it having 12 vowels and 34 consonants. We call it vowels. In Gujarati we call them swars, and consonants are known as vyanjan. So Gujarati OCR required to identify these 12 vowels and 34 consonants. And also many modifiers are also there. And composite characters are there. One important difference which makes Gujarati OCR more challenging is this: in Gujarati, we do not have, Sirolekha, which is there in Devanagari or Hindi. I guess it is also there in Punjabi as well. So this Sirolekha is not there. We do not write Sirolekha here. Word Gujarati is written in Gujarati as well as in Hindi. So you can see in Devanagari, you can see one Sirolekha, a top line is there, which guides you, in fact, the, the OCR algorithm, which differentiate the center part, which separates the center part or center zone from the upper zone. So that guideline is not there in Gujarati. So that is the first challenge in OCR technique. When you use OCR or when you write program for OCR, we do not have this Sirolekha. That is one. Second is modifier. In fact, this is one modifier which is pronounced as ra, ra, right? And if you write this ru, ru, in fact, the word remains the same, but the pronunciation is changed. One modifier is attached with the stem or the alphabet, main alphabet ra, and it becomes ru. So this is another variation of same alphabet ra. So it is called a modifier. This is also different type of modifier. So these are many such type of modifiers are there. Sometimes some modifier are simply added to the character or alphabet without changing much of the shape of the character. For example, here in Gujarati, the first character, there is also one modifier. This is the modifier that we have added along with the word ga, but modifier doesn't change the shape of the character much, whereas here the complete shape of the character is changed by adding the modifier along with the character. So that is another challenge that we have to deal with in Gujarati. Third one is composite character or conjuncted character. Many times two characters are joined with one another. Here na is joined, two na are there, here two na are there, here two the are there, one da and ya, these are there. So that makes anna, yuddha, madhya. This type of words are written by connecting multiple alphabets together. So that adds challenge in Gujarati OCR. The next one is in Gujarati, numbers and alphabet. These three, shapes are there, which are alphabet as well as numbers. This is ra and 2. In digit, it is 2, equivalent to 2. This is a pa, pa, and in number, it is 5. This is ja in alphabet, and in number, it is 4. So there are these three shapes or characters or alphabets which are similar to some of the numbers or digits in Gujarati. So these are 4-5 major challenges that we need to deal with when we are dealing with Gujarati optical character recognition. And of course, if you are dealing with handwritten optical character recognition, then the challenges is more. Another limitation is for Gujarati benchmark dataset is not available. So the first task for us was to develop some data set, and here some data sets are listed out. We have generated a huge data set, and which we are going to make public in short file from now. But the first data set that was developed or created was alphabet and number data set. Here you can see handwritten 0 to 10 is number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the alphabets from here, from this row to this, some alphabets, vowel and consonants are there. So this way we have generated the first data set. In this first data set we have collection of 410 forms, uh, which includes 18,040 Gujarati alphabets and 4,040 Gujarati numerals. So this was the first. This is the first data set that we are using. Second is Gujarati circular, typewritten documents. So we have 114 such documents which we have collected. Then this is the collection of images, 274 images that we have, and in this picture you can see this upper part. There we have Gujarati text as well as number. This is one number 5, and this is another number 25, and remaining are the textual thing. So what we do, for why we have collected this data set, we identify where Gujarati text is written and what exactly written there. So by just giving this text, the pictures, it not only identify, my algorithm not only identify the place where Gujarati text is written, but it also identify what is written over there. uh, Next is we have some very old documents, 50, 70 years old documents are there, which are typewritten documents in Gujarati, and we have 23 such documents, collected documents we have. So in fact, this type of paper is also published, which deals with segmentation of words, or segmentation of words and characters from these old Gujarati documents. So 23 such documents we have. Handwritten Gujarati paragraphs we have 410 Gujarati handwritten paragraphs that we have. And here you can see, if you will, notice this paragraph carefully, then one, slant is also there, skew is also there, some, noise is also there. So this makes OCR more difficult, and that is the challenge for every OCR. This is data set of conjuncted characters. We have, 5 conjuncted alphabet. This is one seat, and one form contains 7 such seats, and we have collected 450 such responses. So this is conjuncted data set. Total number of characters we have is over 50,000. Then we have spoken Gujarati and numbers, which is taken in conditional environment. 45 instances are collected from 250 speakers. And apart from this, we have also generated a corpus for Gujarati, it is Gujarati dictionary kind of a thing that we will discuss later on. But these are the data sets that we have generated, that we have developed for optical character recognition. The first one is very simple type of algorithm, and here from here you will see some of the application of machine learning algorithms in optical character recognition. We give these documents to the algorithm. The first thing that takes place is digitization, and then pre-processing is done. After pre-processing, here feature set is generated, and then feature set is supplied for classification, and number is classified from 0 to 9. And here these are the numbers written in Gujarati script. These are the numerals in Gujarati script, 0 to 9. And most confusing characters are this: 0, 3, and 7. And you will see, you can notice that there is very small difference there in the shapes of this 0, 3, and 7. So if you just add a line of one more cow is there, then it is very easy to misunderstand or misread this 3 as 7 or 7 as 3. Similarly, 1 and 6, these are very close shapes, and 8 and 9, there is just change in difference of this one line in between. So these are some confusing digits. Handwritten, we have collected 300 total, responses. 300 digits are there. These are some small details of the data set. We have, first of all, we have each and every digit in 90 pixels by 90 pixels, and it is written by pencil or pen or different type of different color of ink, and which are written on different types of paper. And by doing this, the shape is varied considerably. You can see here, these are two numbers written on some newspaper paper, paper which is used in newspaper, and we know that the paper of newspaper is clotting type of paper. So the moment you put some ink pen on this newspaper, it spreads, and this is the outcome of the numbers written on newspaper type of papers. So how the ink is spreaded, that you can notice from here. You can notice from here, right? So first of all, we required to adjust those type of thing. So that is done. Contrast adjustment is done by contrast limited adaptive histogram equalization, Clahy algorithm with 8 by 8 tile, and we can get some better result. Then median filter is used for smoothing out the edge of the shapes. If you notice this one, and this one, the edge is more smooth over here. The second shape is also more smooth uh, over here when we have done this to pre-processing thing, median filter. And then after performing median filter, we have put all the shapes into a similar size of 16 by 16. So that is the normalization that is done. The third one is feature set. What feature set was used here? Structural feature set is only used where horizontal, vertical, and diagonal profile uh, is used for constructing feature of individual numbers. So horizontal, how many pixels in 16 by 16 grid, how many pixels are having information horizontally, vertically, and two diagonals. So that is considered as a feature set. And this is what it is. Say suppose here vertically, if we consider 3 by 3, so 1 and 2, this is 1 and 2, these pixels are on, and this pixel is off. So for this 3 by 3 grid, the total number of on pixel is 2. So that is what it is used as a feature set. So this is example of 3 by 3, but we have consider 16 by 16 pattern, and from 16 by 16 pattern, how many pixels are on in each of the rows, each of the columns, and two diagonal, that is considered as a feature set, and that you can see from here. So this creates a features. This is my feature set for numeral identification. One another important challenge which was there in this particular work, and that is the skew. This is handwritten standalone characters. All right. So if it is some paragraph or some line kind of a thing is there in there for OCR, then we can easily find out what amount of skew is there in the paragraph. It is very easy compared to the standalone character, because there in lines and paragraphs we have some baseline, and from that baseline how much skew or derivation is there in the paragraph, that is relatively easy to calculate. Say for example, you can use radon transform to find out the skew in the paragraph, positive skew or negative skew, but what amount of skew is there, that is easy to calculate. But here in standalone character we do not get such type of baseline or boundary line kind of a thing, and that's why what we did, okay, instead of find out the amount of algorithm, the skew, and that's why say this is my one standard character, and then rest of the five character are generated for training. Rest of the five characters are generated by clockwise and anti-clockwise skew at the interval of 2 degree. So this is this is standard character. This is character which is generated for training, of course, generated by rotating that character by 2 degree in clockwise direction. This is another 2 degree, that is 4 degree, that is 6 degree, 8 degree, and similarly in clockwise also we have generated 5 more characters. So total 10 degree in clockwise and 10 degree in anti-clockwise skew is taken into consideration. So the training set, in addition to that data set we have generated, this is on additional data is or additional shapes or additional numbers are generated with the skew. So this is also used for training set, and this is standard graphics equation for rotating the shape, and that shape rotation is used for for generating training data set. And this is my the technical detail of artificial neural network, which is used for training and testing uh, the handwritten Gujarati numerals. So the total number of input layer, total number of neurons used were 94. Why 94 is required? Because 16 by 16, one character is divided into 16 by 16 grid or 16 by 16 pixel, and we are using all vertical, diagonal, and horizontal sequences that makes 94 details. 94 information, and for each one of the rows and columns and diagonal, we have one feature. So total 94 features are there in a feature set, which are provided to my neural network. In hidden layer, 50 neurons are taken, and in output layer, obviously 10 neurons, because it is we want to identify 0 to 9, so there are total 10 digits to identify. So each one of the neuron in output layer is taken for one number. This 50 is derived by some trial error method. There is no standard method which determine the number of neuron to be considered in hidden layer. So 94 neurons are there in input layer, 15 10 neurons in output, and 15 neurons in hidden layer. Transfer function is hyperbolic tangent tensig is the sigmoid function. Of course, a sigmoid function is required. So hyperbolic tangent sigmoid function is used for transfer, use as transfer function, and logistic function, sigmoid function, once again logarithmic sigmoid function is used in output layer, and back propagation, gradient descent is used. Train GDX is used for training, as a training function. So when we train our software, I mean the algorithm, and test our algorithm, then this is the output that we received. There were total 61. The standard division of data set should be somewhere around 70 to 75 for training a data set. 70 to 75 percentage of data should be used as a training data set, and remaining 25 to 30 percentage should be used for testing purpose. So training data set and testing data set, and if we train and test this, the total average result that we received was achieved was 81 percentage of 81.66 percentage of accuracy or success rate. And you can see here, we noticed one thing, and I I have shown you that 1 and 6, these are two very problematic numbers. And as you can see here, the accuracy of 6 is very less. The least accuracy that we achieved in this particular result, that is 60 percentage. And similarly, if you see relatively, this two is also less, 92 percentage and 84 percentage. That is also less, because we have noticed that 8 and 9, they are also very close to one another. And similarly 3 and 7, they are also very close. So 67 percentage of result is here, and 7 is relatively high, but this is also very less. So that is the result of the first experiment or first work, which shows 81 percentage of average accuracy when we used artificial neural network as our machine learning algorithm for standalone handwritten Gujarati numerals. In the second, we have changed. We tried to change the feature set. There were 94 features, there. So here we tried to reduce the feature set, and we have also tried with different types of algorithm, KNN algorithm. So what we have done, this 16 by 16 grid, 16 pixel by 16 pixel, they are further divided into 4 by 4 pixel sub image of 4 by 4 pixels. And in each one of these 4 by 4 pixels, 4 by 4 sub image, how many pixels are on. So suppose here in this particular 4x4 sub image, 1, 2, 3, 4, 4 pixels are on. This is 1 pixel, this is second pixel, this is third pixel, and this is fourth pixel. These 4 pixels are on in this sub image. There is no pixel on in this first sub image, so this is 0. The second one is 4. The third one is having 1, 2, and 3, and fourth one is again 0. So this is one row, again 0, 0 is here for this sub image, and that is how we have generated a feature of 16 features. In addition to this 16 features, we have added one more feature, and that is the aspect ratio of that particular number or that particular numeral. So that is how now this feature set is also reduced from 94 to 17 only. Okay, and here we have used KNN algorithm. The best thing to use any machine learning algorithm is you should try out with different types of parameters, which will give you the best result. And here I have used various type of uh, various number of instances I have used for training and testing the data set, and this is what the results that obtained. And the best result that we obtained was with k value 1. When k is equal to 1, we got the best result, and this is my total accuracy, and this is my accuracy of testing data. This is accuracy of testing data. Earlier I got 81 percentage of accuracy, and now the and feature set is reduced, and I have used now KNN data set. I mean KNN algorithm. This is my accuracy. I have reached up to 96.99 percentage of accuracy. This KNN algorithm is a lazy algorithm. When I say KNN algorithm, a lazy algorithm, the meaning of lazy algorithm is all the calculated data is very much there inside algorithm itself, and that makes it easy. Whereas this artificial neural network is more time consuming algorithm. So KNN is equal to 1. I mean k value is equal to 1, and n is 25. It is 87 accuracy was there, but I have increased n is equal to 150. That means it is approximately 60 percentage of data I have used for training, and when I used 60% of data for training and 40% of data I have used for testing, my accuracy has reached up to 96.99 percentage. The third one is on alphabet. I have not put anything on complete OCR, but I just wanted to show you, share with you the use of different types of machine learning algorithm for optical character recognition purpose. And these are the result of some, offline optical character recognition uh, experiments or the projects. There are total 40 alphabets I considered for recognition. Now, the first two are the examples of numeral identification or numeral recognition. Now, here it is alphabet recognition. So, total sample collected were from 200 writers. So, total we have 800 alphabets. Every alphabet or every document is scanned in 300 dpi depth, and total 17 features are considered. Similar features that we have considered in the last example, this example, same feature set is used for alphabet as well. So here this 17 feature set is this 17 certain features is used for numerals, but similar feature set is used here for alphabets. But this time we are using support vector machine. Support vector machine for one against all approach. There are two types of approach in SVM. Basically, SVM is not used for or not meant for multi-class classifier, but we can use SVM different little bit differently for multi-class classifier as well. So we have used these two different variation of using SVM is one against one and one against all. Say one against one is suppose there are 1, 2, and 3. 1, 2, and 3 classes are there. So what is done? 1, 2, 3, and 4 classes are there. So the first one is this one is considered with 2. This 1 and 2 is considered. 1 and 2 is considered. 1 and 3 is considered. 3 is considered for SVM. 1 and 4 is considered for support vector machine to classify. Then 2 and 3, 2 and 3, and 2 and 4, 2 and 4, and the last one is 3 and 4. Against this, one against all, in one against all, what is done? Okay, one is compared against 2, 3, and 4, 2, 3, and 4, 2, 3, and 4. Similarly, 2 is compared against 1, 3, and 4, 1, 3, and 4. 3 is considered against 3 is considered against 1, 2, and 4, 1, 2, and 4, and 4 is compared against 1, 2, and 3, 1, 2, and 3. So this approach is known as 1 against 1. This approach is 1 against 1, 1 against 1, and this approach is considered as 1 against all. Rest of the all remaining 1 against all. So in this algorithm, in this proposed algorithm, we have considered 1 against all. Obviously, this 1 against 1 is more time consuming. So we have used 1 against all, and this is the comparative result. Uh, we have also compared the same thing, alphabets, with different types of algorithm. We have used compared it with KNN. So what is the difference between these two tables? Here feature set is hybrid and feature set is structural. There is one, in this particular table, total features used was 17. And in this 17, this aspect ratio was also there. Aspect ratio is also there, and that makes this feature set a hybrid feature set. So what is done here in the lower table, okay, we have dropped out that hybrid, this aspect ratio feature, and remaining 16 features were used for identification. So the best result through SVM that we received was 86 percentage over here for hybrid, and here in this structural, the best result that we received was 85%, 85.90%. So this is how one against one or one against all SVM is used, and we achieved this output. Let me share with you one fact that very little work is done in Gujarati OCR. Probably these were the first ever papers which were published in journal, which were addressing handwritten Gujarati OCR. Before that, I could not find out even a single paper which has deal with handwritten number or handwritten alphabets for optical character recognition. Here, language processing task is, grammar analyzer is done for Gujarati language. So mainly three things are considered in grammar analysis. The first one is syntax analysis. This syntax analysis tells whether the grammar or the sentence which is written is grammatically correct or not. What is the meaning of the sentence? That is analyzed by semantic analysis. Formal grammar, in formal grammar, context-free grammar is, one of the grammar. What is formal grammar? A system of rules for generating sentences is a formal grammar, and I will show you some of the rules of Gujarati grammar or Gujarati language. So the first is syntax part. Uh, what is, in fact, my interest is here. My interest is in Gujarati, but the similar sentence is written in Hindi and English as well. So syntax analysis is a process that analyzes the structure of the language. Structurally, whether my composition of my sentence is correct or not. For example, here Sachin khel khelta hai, it is a correct Hindi sentence. But hai Sachin khelta khel, this is not grammatically correct sentence, right? And similarly, that is translated into Gujarati, which says something like this: Sachin ramat rame chhe, which is correct, but Sachin chhe ramat rame, which is wrong. And English, Sachin is playing a game, or game is playing Sachin. This is wrong, right? So our objective was to analyze whether some sentence which is written in Gujarati is grammatically correct or not. That is what we wanted to check. Okay. Semantic analysis is a process to analyze the meaning of the sentence written in natural language. That includes some very interesting type of things. We have not, though we have not, done this type of semantic analysis. We have not done yet. But what are the challenges there? This is true for all the languages, not only for Gujarati or Hindi or English. I am sure that in Punjabi language also this type of situation must be there. It is based on structure of the sentence. There are some sentences which are different syntactically. They are different but carries same meaning. Now I am talking for the semantic, from the semantic point of view. The structure of two sentences are different, but they carry similar meaning. For example, Virat plays cricket before 9 o'clock, and before 9 o'clock Virat plays cricket. From the syntax point of view, both of these two sentences are different, but they have similar meaning. So here in syntax part, we first of all we check whether the composition of that sentence is correct or not. So here it says yes, both of these two sentences have correct syntax. Syntactically they are correct sequences. They are having correct sequences. So they are correct sentences, but the meaning is same. So that is true in Gujarati as well, and you will find out that that is true in your language, your mother tongue also. That is true in your mother tongue as well. So the first one is two different sentences but similar meaning. Here one sentence with different meaning. For example, the dog entered my room and it scared me. This is one sentence is one. The second sentence is I saw the man in the park with a flower. So the first sentence, the dog entered my room and it scared me, it is correct sentence. But there is one repetition of word, and this repetition of word is eat. Now this eat is referred to what? This eat is referred to the dog, or it is referred to room. You know that creates some ambiguity. Whether this eat is referring to dog, the dog entered in my room and I get scared of the dog, or the dog entered in room and because of dog is there in the room, I am getting uh, scared of that particular room. What is the meaning? So when translation takes place, translation of language takes place, then that creates problem. And similarly, I saw the man in the park with a flower. So this with is referring to the man with a flower, or this with is referring to the park with a flower. So here sentence is one, but meaning are different. And here I have written similar example in Gujarati for explaining this one sentence in different meaning. The third one is one word with different meaning. And you know that bank is a word which has got multiple meaning. Plant is a word which has got multiple. I am referring to what type of plant, whether it is a biological plant or some manufacturing plant, factory plant. So what plant I am talking about here? What type of bank I am talking about? It is financial institute bank, or a river bank, or sisho. What I am referring to this. So the first one was in when you are dealing with semantic, the uh, different structure with same meaning, one structure with different meaning, one word with different meaning, and there are some correct structure. This is very well known. The students of natural language processing, they must have heard this sentence. This is structurally correct sentence, but it doesn't carry any meaning. Colorless green ideas slip furiously. It is in English correct. It is structurally it is correct sentence, but it doesn't carry any meaning. So colorless is an adjective. Green ideas is noun or noun phrase. Sleep is a verb. Furiously is adverb. So colorless green idea is adjective and noun phrase, and sleep furiously is verb phrase. So noun phrase is followed by a verb phrase. It is a valid sentence, it is a correct sentence. But if you look at the meaning from semantic analysis analytical point of view, though it is a correct sentence, syntactically it is a correct sentence, it doesn't carry any meaning. So in semantic analysis, these are four major challenges. So in syntax analysis, the sequence is a challenge. Every language has got their own grammatical rules, and we have to follow those rules. And that is the reason why most of the cases, the syntax analyzer written in one particular language cannot be used for other language. That is one of the reason. When it comes to semantic analysis, these are four challenges. A different statement, I mean a different structure, but having same meaning. One sentence with different meaning, one word with different meaning, and correct sentence, grammatically correct sentence, but doesn't have any meaning. But here I'm going to discuss uh, Gujarati grammar analyzer that we have developed, that we have created. For that, we have used context-free grammar. So what is formal grammar? A set of rules for generating valid sentences in a natural language is formal rule. and one of that rule is context-free grammar. And context-free grammar is a set of recursive rules used to generate patterns of string. For example, in Gujarati, what is a context-free grammar rule? What is a rule? If noun is followed by verb, then that makes a correct sentence. Right. So noun in Gujarati, noun is called karta, who does something. So that is karta, and this karta follows by a kriyapad, that is verb. So I am looking for this sequence. Whether this sequence appear in my sentence or not, and if this sequence is makes a sentence, then that sentence is a correct sentence. Otherwise, that sentence is not a correct sentence. So first of all, what I need, if some statement which is written in Gujarati, first I need to identify which are the verbs, which are the karta, which are the kriyapad, that is noun, verb, pronouns, adjectives, proverbs. I need to identify all these, parts of my Gujarati language. And for that, there are two types of symbols which are used. One is terminal symbols and non-terminal symbols. What is terminal symbols? The terminal symbols are those symbols or the words in natural language which are called terminal symbols. And symbols that make sentence but actually not the real word in the language which are used in the language, they are called non-terminal symbols, like the tags. So suppose here I am writing this Virat likes playing. So Virat likes playing is the sequence of terminal symbols where each one of the tokens Virat likes the bat, they are written in terminal symbols. Why? Because all these words are available in English language, and that's why those are the symbols which are known as terminal symbols. Whereas each one of these words is identified differently. For example, Virat is a noun, likes is a verb, the is a determinant, and bat is again a noun. So, in fact, this Virat likes the bat is nothing but NVDN, which are the tags. N is tagged for a noun, V is tagged for the verb, D is tagged for the determiner, and N is again a noun. So these are the symbols, or this is a statement written in non-terminal symbols. So what we want, first we want to identify non-terminal symbols for the sentence, and then based on the rules we check whether this sequence of non-terminal symbols is correct sequence or not, and if it is in correct sequence, we identify that statement as a correct statement in Gujarati or any language. So here, that is called rewriting rule. In fact, what is rewriting rule? The rules that converts non-terminal symbols into terminal symbols, they are called rewriting rules. And for that, I need to have one corpus. I need to have all the noun collection of all the nouns, all the verbs, all the determiners, all the prepositions, all adjectives, and all other part of speech that are available in any language. So we have to, collect these symbols. Now here you can see in noun, Virat is there, likes is there, play is there, bat is there, So using this, we can, convert this terminal rules into non-terminal rules. So as I told you, yeah, we required the sequence in non-terminal rules. So what is Virat? In fact, there is one noun phrase. There are two phrases there. One is noun phrase and another is verb phrase. So what is noun phrase? If standalone noun, that also makes noun phrase. and a determiner and noun, that also makes a noun phrase. For example, if you just write Virat, then Virat is nothing but a simple noun, and that's why is a valid noun phrase, right? And similarly, the is a determiner, bad is a noun, so it is combination of a determiner and a noun, so it is also a correct noun phrase. As you can see here, okay, what is noun phrase? A simple noun or a determiner and noun, it is a valid noun phrase. So this is the example. Virat is example of a simple noun, and the bad is an example of noun phrase where the is determiner and bad is a noun. So these are couple of examples which frame the noun phrase. Similarly, we have verb phrase. There also a valid verb phrase is what? Valid verb phrase is of a simple or a single standalone verb, or it may be a combination of a noun phrase. And again, noun phrase is that may be of a simple noun or a noun phrase, or determiner and a noun, right? A determiner and a noun. So that is what the thing is. So here first like is there. Like is a standalone or one single verb, and that is why it is a correct verb phrase. And here likes the bed, like is a verb, and the bed is noun phrase, so it is a valid verb phrase. So this is a verb phrase, like is a verb phrase, and likes the bat is also a valid verb phrase. So here you can see the mapping between non-terminal symbols and terminal symbols. And then finally, a sentence. What is a valid sentence? Valid sentence is noun phrase is followed by a verb phrase. So if in any sentence, if noun phrase is followed by a verb phrase, then that is a valid sentence. So now look at this. Virat likes the bat. Virat likes the bat. What is it? Virat is a noun. Virat is a noun, so it is a valid noun phrase. Likes the bat, where like is a verb, the is determiner, bat is a noun, so the bat is uh, you know is a noun phrase. And here verb and noun phrase makes a verb phrase, so there is sequence of a valid noun phrase and valid verb phrase. That means Virat likes the bat is valid sentence. Virat likes the bat is valid sentence. Now look at this. If you simply write Virat the likes bat, Virat the likes bat, like is not the is not here, the is not here, but the is here. Virat the likes bat. So this is Virat is a valid phrase, but the like bat will not be a valid verb phrase. So this is valid, but this is invalid, and that's why this Virat the likes bat is turned out to be an invalid or a wrong English statement. So that is how you can check, you can verify the grammar of any language. So now, in the perspective of grammar analysis, let us check Gujarati. What is the typicality of Gujarati language? Gujarati is a language belonging to Indo-Aryan family. That's okay. Gujarati words are divided into 5 grammar classes. That is part of speech. There are 5 main part of speech that are there in Gujarati. One is noun, we call it karta. Pronoun, adjective, we call it visheshan. Verb, kriyapad, adverbs, and other words, These are five, part of speech. Then there are some cases and structure of the language. Noun admit in inflectional to express number. There are number, gender, and case. So what is number? Number is singular or plural. So if chokro, it is a single boy. In Gujarati, chokro is a single boy, whereas chokrao, it is multiple boy or many boys. Similarly, so it is written chokro. Chokro means boys. Boys is masculine name. So this is written in masculine name, and similar thing is written in written for feminine. So chokri, chokri is feminine word. So here it is different gender. Masculine. There are three types of gender cases: masculine, feminine, and neutral. So one word chokro boy. So it is chokro. Same word for girl is chokri, and for neuter it is chokaru. So there are first one is number case, second one is gender case, and third one is case nominative, agentive, accusative, dative, genitive, instrumental, and locative. So it is one, two, three, four, five, six, and seven cases are there, and these are the example of each one of these cases. Gujarati nouns are formed by noun stem, and then how any word in Gujarati, any noun is created. So noun stem is there, so root word is there, root noun is there, and then gender marker, number marker, or case marker is added. So here, chokrao, so this is boy. Here it is gender marker. Here O is a number marker and Ne is case marker. So the word which is there in Gujarati is boys, chokro, chokrao, I cannot write it properly. Chokra one. This is my word. Chokra one. So this word is, composed by, this is stem or a root word, chokar. Then a, here this I is added. It is gender marker. I am talking about multiple boys. So it is, uh, number marker O. So here it is O. And then case marker two boys. So here ne, that is added, and that is ne. So that is how one noun is formulated in Gujarati. So here also we have created our own corpus of 29,046 root words. 29,046 root words we have considered, and then we have major root classes of databases are, there are 218 pronouns, we call them sarvanam. Propositions, 135 propositions are there, which are called nam yogi in Gujarati. Markers are there, 61 markers. Adverbs, 226 adverbs. Common nouns, 21,856 common nouns. Adjectives, 5,690 adjectives. Kriyapad, 1003 and 1003 verbs are there, and auxiliary words are there, 614 auxiliary words are there. So this is again the corpus we created in house, and then this is the analyzer that we have used. I skipped this analyzer for now because 15 minutes are only left. So the first one is morphological analysis. In fact, in the initial stage, we have not used machine learning. But if you will see this block diagram of grammar analyzer, then here at this stage we have used artificial neural network. And why artificial neural network is required, that is also interesting. And we have used artificial neural network in a little bit of variation, with little bit of variation differently. So what is done? So Gujarati text is supplied. First, every word is token is separated, and then on the every token morphological analysis is performed. Then tagging is done, and from after tagging, artificial neural network is used for some particular purpose. What that purpose is, that I will share with you in a couple of minutes. And then ultimately I check whether the composition of that Gujarati statement is correct or not. So I have discussed this morphology over here. This morphology over here, Chokrao ne. Here I have discussed this morphology. So there are two types of uh, morphology. One is inflectional and derivational. These are some of the example of inflectional morphology and a derivational morphology. Uh, Here in inflectional, simple markers are added, whereas in derivational, some words are also added. Right. So in derivational, a new word is created, whereas here some simple markers are added. So that is when markers are added, it is called inflectional, and words are added, there is derivational. So what is done? We have used that similar thing, chokra o ne. So first we check for 8 case marker, whether any case marker is there. So we are checking from right to left. We are checking from right to left, and as we have seen, the last marker which is added is case marker. There are 8 case marker, so we check whether any one of the case marker is present in the word or not. So we check whether any any case marker is there. Here this case marker is there, nay. So part of speech is first word is there, and what is the order? On the first place is place, this case marker is there, so order is 1. So remaining word is chokra o. This is the remaining word. So first nay is separated out, the first marker is separated out, and remaining word is given to the next scan. And again we check. Now this time we are checking for number marker. Is any number marker is there, singular or plural? So there are two number marker. So is any one of these two number marker is present or not? Still the word is one. Your part of speech is one only, the first word only, so it is one. And is number marker is there, so we say yes, number marker is there. O number marker is there, so second suffix is also found there, marker is also found there. So first was ne, now second marker is o, so that is separated. Now remaining word is again given for the analyzed for the third time. So in this case 3 markers are there. So these 3 markers, not number marker, but these 3 markers are which 3 markers? Here we have mentioned uh, case marker, gender marker, and number marker. So 3 number markers are there. So that is here it is wrongly written. This is gender marker. This is gender marker, and now last one is the number marker. So number marker is there, so we say yes, I is there, so I is separated out, and then the last one is checked. So what is the algorithm? This algorithm is there. This token is given. We check this token with the corpus of the root word, whether this word is present in the root word. We say no, that root word is not present in the corpus, so we check whether case marker is there. So we found case marker, so it is removed. Remaining word again checked with the compared with the corpus of stem words. Do we found any such stem word there in the corpus? We say no, it is not, still not there. So gender marker is there. Yes, gender marker is there. So gender marker is removed. And once again, it is checked whether now chokra is there is in the list of my root words. So still this chokra word is not found there in the list. So it is again checked. If it is not found, then is there any number marker there? So number marker is also found. So number marker is removed, and again it is checked with the corpus, and this time it finds out the presence of this word in the list. So now from this chokrao ne, root word is found, and this root word is. Similarly, Sundar is a word. I guess Sundar is understandable by everyone. With this word is also there in Hindi. It is adjective also, and it is a proper noun also. Someone's name is possible. Sundar Nam name is also possible, and it is Sundar face. So in that case, when it is used Sundar face, it becomes Sundar becomes adjective, and his name is Sundar, so it is the proper noun. So when Sundar word is written, then two tags are possible. This will be Sundar will be tagged as an adjective, or it may be tagged as a normal or proper noun. So that is a problem. But in morphological analyzer, uh, these are some of the work since 2001. There is one Punjabi University work is also there on Hindi, but it is missed out in this from this list. But ours is on Gujarati, and there are three such work found in the language of Gujarati, and our work stays over here. Sheffield University also done for Gujarati word, but that data set is what is the paradigm that is not available. The 30,000 words that is there, but what is the accuracy? They have not. We could not find out the accuracy of this word. And DDIT Nadia, they also done it this type of work. They have claimed 98 percentage of accuracy, but the test data set is very small uh, for them. And here we have 30,000 plus lexicon size. Test data size is 2000, and our p value is 82. But the problem is what? Problem is there are so many words which get multiple tags. So POS tagger. So what exactly we have done over here? Okay, here some word is written, and here again a similar example is considered, where this Ramato and Rame, these are two words which gets multiple tagging. So can we get a single tag for each one of the token which is included in the sentence? So for that we have done rule based system. We have applied some rule based system. Here we have used rule based system, and we have formulated 8 rules. These are Gujarati rules, of course, Gujarati rules, but we have translated those Gujarati rules into the program form. So the first rule is what? If current word, we are checking now, che. Current word is either noun or word, and next word is auxiliary verb. We are checking rame and che. We are checking for this. So current word is what? Rame. Either noun or verb. Yes, it is noun or verb. It is noun or verb. It is identified as noun or verb. And the next word is auxiliary word. Che is auxiliary word. So it satisfies this Rameche satisfied this first rule. And if it is there, if current word is noun or verb and the next word is auxiliary verb, then the current verb shall be main verb. So here, though it is identified as noun and verb, now it is no more a noun, it is verb only. So now noun and verb, these two tags were identified in the last phase, but because of this rule-based system, now it is just a verb. And if we use a second rule, if current, now we are talking about Ramato and Rame, where Ramato is noun, feminine noun, and Rame is verb. This Rame is given verb from the last rule. So now we are checking for this word. This current is noun, feminine, and verb. So if current is noun or a verb and next one is verb, then the current shall be noun. So here it is verb. This is now verb, and this Ramato is noun and verb. This two possibility ambiguity was there, whether it should be considered as noun or it should be considered as verb. So by this rule number 2, it says that it has to be noun and it could not be a verb. So now what is the composition? Now each one of the token has unique single tag. So first one is noun, second one is noun, third one is verb and auxiliary verb. So this is now noun phrase and this is now verb phrase, and according to this is now correct Gujarati sentence. So we have 8 such rules. I have, you know, give you example of 2 rules, and similarly 6 more rules are also there which are used for, you know, removing the ambiguity in the tagging. So this is the snapshot of that particular environment. Now here we are using, I can I take 10 minutes more? Hello?
Sure, sir, sure.
Yeah. So now what we have done, we have, given tags to each and every token, but still the correctness is left. Whether the sentence is correct or not, that is left. So how to check it? The main problem is the sentence length is variable. That is the main problem. How many words will be there in a sentence that we don't know? There could be, 3 words, 5 words, 7 words, 10 words. How many words? How many words will be there in a sentence? Which we are checking whether this sentence is correct or not. So the one is what? Okay, we can have, and suppose we want to, use neural network. Neural network will, easily tell whether this, sentence is correct or not. Where in neural network, in input layer, we can give how many nodes are required in input layer. The nodes, as many as words there in the network, that many words are, or that many nodes are required in input layer. And in output layer, 0 or 1, only one node is required, which tells me whether sentence is correct or not. Right. So one approach is what? For each and every tag, or sorry, each and every token, take separate neural network. But that is, not a good idea, because that is as good as checking every single word. So that is, directly that cannot be used. So this second number is useless. Second approach is what? Okay, you design one neural network for a sentence which is having 2 tokens, neural network for 3 tokens, neural network for 4 tokens, neural network for 5 tokens, but that is also not manageable. All right. The third approach is what, which we have used. The third approach is an approach which is sliding window approach. What is that sliding window approach? In sliding window approach, suppose there are these 1, 2, 3, 4, 5, and 6 words are there, 6 tokens are there. So you check first two tokens together and supply output of this neural network to the third one. So now output of this, that is O1. O1 is taken with this. Say this is O2, that is token with the fourth token. Output of this is O3, that is taken with the fifth token. Output of this which taken is this taken. This is two-word window. This is two-word window. Right, this is two-word window. And similarly, you can see here window size 2, O1 and CN1, that is taken. Output of this is taken as O2, and O2 and this J1, that is considered, and that is how it goes on. Right. Here in this example, that three size window is considered. Three size window is considered. So this accommodates a sentence of any length. This accommodates sentence of any length, right? And here, this is one example. So what is it? So the first output is this one is O1 and C1. So that is O1, that is 0 or 1, 0, 0, 0, 1, 0. What is the output, final output? That is, this is the example of a sentence which are having 16 words. These are having 16 words in it, 0 to 15. So these are the words, and with every one, what is the output of that neural network, that is I mentioned over here, that goes over here, and that is how the correctness is checked. And for this, we have Alman's network we have considered. The details are over here. Where is it? Detail. Where are the details? Alman's neural network is used. I have missed the details. So input neurons are 8. Hidden neurons there are 20. This is an example of ERNN network, and this is the training graph. Error versus repose. Look at this, how error is reduced. This is the example of error chart of size 2, and this is error chart of size 3. You can see the two error window size is 2. When window size is 2, we can reach to the minimum error at 200 to 1251, whereas here we need to go up to 2001. And this is the example, I mean result of our example, our you know uh, result, and we got 99 percentage of accuracy for training data set, whereas test data set our accuracy is 78 percentage. Punjabi University has also done a similar kind of a work for Punjabi language, and they achieved 76.79 percentage of accuracy for testing data set. And you can see here, there is no other work, similar kind of work which is performed on Gujarati language. So what we have done, we have done in Gujarati, we have done morphological analyzer, then tagging, then tag ambiguity resolving process, and then we have used machine learning for uh, checking or predicting whether the sentence written is correctly or not. And by doing this, for unseen data or test data, we got 78 percentage of accuracy. And here, this is the speech to text, but I will not go into this detail. And these are some of the papers based on which is today's presentation is created. So that is it. That is what we have. That is the some of the examples that we have uh, done in our department on Gujarati language. I have considered some of the simple cases for demonstrating the use of various machine learning algorithms in Gujarati natural language processing. Thank you very much. Thank you.
Thank you, sir. Thank you very much. Any question from the audience? So I can see in the chat window, the audience want to ask about the implementation of syntax and semantic analysis, some practical aspect. What practical language you have used for implementing all these technologies, whether it is Python or something else?
Yeah, initially we did it in MATLAB, but yes, we have used Python.
Okay.
Python is relatively simple for language processing.
Okay, sir. Thank you. Thank you very much. Any other question from the audience? You can ask directly instead of writing in the chatting window.
Yeah, there is something. Is there any standard benchmark database for Gujarati? No, benchmark dataset is not there, and that is the reason Dr. D. Sudha is asking, is there any standard benchmark dataset for Gujarati language? No, standard dataset is not available, and that's why we have created this dataset for our purpose, and we can use, if anybody is interested, we can provide that dataset for your research purpose. Uh,
Okay, sir. Okay.
So, Ms. Vidya want to ask whether there is any site where we can see the research paper on this topic.
You can communicate with me if anybody is interested. I can share a research paper with you. My email ID is aadesai Ahmedabad Desai at vnsgu. Let me go to my first slide. I have put my email ID on my first slide. It's not there. Let me write over here so that you can
You can write on the chat window itself.
yeah. Okay, let me share.
So it is aadesai at vnsgu.ac.in. So one more question is there, how part of speech tagging is done? Is there any specific parser for this?
No.
So it is rule based?
Yeah, it is rule based.
Yeah.
It is rule based.
So any other questions from the audience, from the participants? Okay. That's all. Thank you, sir. Thank you. You have nicely explained the concept of machine learning. Your explanation are such that even a new learner can understand it easily. Your explanation of machine learning algorithm as used in various NLP tasks like OCR and grammar checker is really good. So I hope participants have some idea about the machine learning and how it can be helpful, and they can apply the similar techniques in their own research. Thank you, sir. Once again, thank you very much.
Thank you. Thank you very much for giving me an opportunity to interact with the scholar from all your area, sir.
Thank you, sir.
Thanks a
Thank you.
lot.
That's our pleasure, and so nice of you that you have given the time for in a very short time. So we request you, and we give you very little time for the preparation. We are sorry for that.
No problem, sir. Thank you very much.
Thank you, sir. Thank you very much.
Bye, sir.